Hello to episode number 7 of Hello Rust. I'm Matthias Entler, and last week I handed out a challenge to parse a human readable date format, which consists of a day, a suffix, a month, and a year. I received a couple of submissions both via email and via GitHub, and I'd like to thank you for that. Today I want to introduce you to my solution, and we talk a bit about testing and making sure that the parser actually works. All of this right after the intro. Okay, so here we go. First, let's define our input. We say parses a human readable date format. And let's give it an example. 4th of July 2018. 2nd of March 2006. 3rd of November 1985 or 75, yeah, whatever. By the way, if you haven't tried that at home yet, go give it a shot. I will wait for you. So back on track, we have a function, let's call it parse date, and it takes a t, which implements as ref of string. And if you don't know what sref string means, then I recommend to you to watch the previous 2 episodes where we talk a little bit about that. The return value is going to be a result of chrono naive time and a custom error type. I chose chrono because it covers a lot of different date formats, and it's kind of a standard in the Rust ecosystem. You can check out the documentation for Chrono on the Chrono website on GitHub. You can check out the documentation on their API docs. It's a nice read. You can learn a lot about Shakespeare, for example. And it's kind of cool, and that's why I chose it. I don't want to reinvent date time parsing because it's a very, very messy business. But of course, for that to work, we first need to import Chrono here. Actually, let's say I'm unimplemented here so that we don't get a compile error right away. So we say extern create Chrono. Use chrono naive time, naive date. Down here as well. Cargo at chrono should be in our cargo toml now. Okay. Let's define an error enum. I guess we will have some kind of parse error. And an invalid date error. I want to use the parse error whenever we have an error with our string input format. And I want to use the invalid date error when the parsing worked, but we cannot represent the input data as a correct date. So for example, 28th of February is not always a valid date because of the leap year and stuff. So I guess I want to make this error public, and I want to derive a few things. Debug and partial equal. It's gonna be nice for testing. One hash too much. Does that already build? Okay, great. Then let's start implementing our parseDate function. Of course, there are many ways to handle this situation now. One can think of regular expressions, but I want to go and do something very simple first, create some kind of prototype, and then we go from there. So I would just split the string into tokens and then analyze each token as we go. Let's see. So, okay, first we need to split the input string. I don't like the name T. Let's think about some other name, human date. Okay, let parts equals human date dot iter dot split white space dot collect. And you want to collect into a vector of strings. In fact, we don't need the iter here, but we need to call sref on it. So to get a string reference, and a string reference implements iter, so there we go. And I guess I can map the input string with string from to string elements. Otherwise, I guess I would work on, I don't know what split whitespace returns. Actually, I can save myself some allocations by using a string slice vector. Sweet. Now let's do some sanity checks. If the length of our parts is not 4, then we received something unexpected and we just return an error. Parse error. And to get on with our test-driven development, in any other case, we return an invalid date error. Oops. Let's write a test. Use superstar to import our dependencies into the namespace. Parse date. Human date is going to be the 4th of September 2015. And we expect, what do we expect? We expect an OK naive date from year, month, day, and the year is 2015, the month is 9, and the day is 4. Missing semicolon. Okay. Cargo test. And we get a compile error saying the trait convert sref string is not implemented for stir. Well, because we don't want a string here, we want a string. We want a stir. Of course, we get a failure because we haven't really implemented our function yet. So let's try to parse this date format. In the beginning, let's just hard code our example. Let day equals, what was it? 4th of September. Okay. Day equals 4. Let month equals 9. Let year equals 2015. And we're going to return a naive date from year, month, day 2015 9 4. And let's wrap it into an OK. Great. So we have our first passing test. Although we cheat a bit, and that becomes apparent when we change the date. If we want to parse the 5th of September, let's move that outside. Okay. How do we fix that? Well, now we need to do the actual parsing. The human day comes from parts 0. The month comes from parts 1. No, parts 2, because parts 1 is the suffix. We might want to check that. Okay, parts 2 is the month and parts 3 is the year. The day consists of a day and a suffix. So what we have to do is we need to check for that and take the first two elements, the first two characters. That's kind of unsafe, but I guess we can improve upon later. For now, yeah, let's just roll with it. Let's just name this day with suffix and day equals day with suffix 0, 0, 2, 2. And we should parse that and return an error with the question mark, and we parse it into an U32. If we tried to compile that, it wouldn't work, because it expected a parse int error but found an enum error. That means our return type is not compatible with whatever parse returns. But that is easily fixable by writing an impl from std num parse int error for error. Fn from takes a t where t is of this type, and it returns an error. This should be parse int error. Good, at least the conversion works, and we can carry on. Next thing is going to be the month. We simply call parse on it, and we also expect a U32. Actually, a U8 might be enough, but I guess naive date expects a U32 as far as I remember. Year is going to be the same. And we can insert it here. Forgot the question marks. Day for some reason needs to be an I32 and not a U32. It's a bit confusing to me. So it does compile, but it still fails. We get a parse error. That's because our day is only consisting of one character and not of two. If I, oops, yeah, of course, for both cases. Up here as well. And then it would, well, of course, the month parsing is not working yet. Because we need to have a mapping between a string and an integer. But for now, for a test, let's just add September. Let's just add a 9 in here. Okay, two things. First, I need to switch year and day here. And then it should okay, now it all makes sense. This day is a U32, the year is an I32, because there can be a negative year, so -1, -10 years. That will be before Christ. Date-time parsing is so hard. But still, I'm a bit confused about why our first attempt panicked. So I was reading the documentation a bit, and it turns out that there are two ways to create a naive date. One which will panic and one which will not panic. So if you call from year month date, from year month day, it can panic. If you use from year month day opt, it cannot panic, but it will return a result. I have to say that's a bit unintuitive, and I hope that's gonna be changed sooner rather than later. But it is what it is. And for now, I guess we will switch to the _opt version. So from year month day opt. And that's already gonna return a result. So I guess I can do that. Correction, it returns an option, not a result. Personally, I think that a result would be better in this case because it expresses the idea that there can be an error, whereas in an option type, it would just say there is something or there is no value. But to fix that, we can say okay or else error invalid date error. Like this. Oops, without the error here. Next, let's handle our month. We need to convert from a month string, like November, the word, to some kind of digit. There's a couple of ways to do this. One would be to use a simple map and map from the string to the integer. Another one would be to use a vector. In this case, I guess I prefer a vector because it's gonna be a fixed length, and the digit that we're gonna return is defined by the position in the vector. So January is gonna be the first entry, so it's gonna be number 1, all up to number 12, which is gonna be December. But I guess I still want to have some kind of function for this. Let's create one. So let month equals get month let's call it get month number. It's also gonna return a result. And it's going to be a bit like fn get month number. The input is going to be a string. Yes. Returning a result of U32. Let months equals vector January, February, now we need to try to make the lookup in our vector, and we can have two cases. One is we find an element in the vector. The other one is we don't find one and we return an error as a result. So there's a very nice handy function to get the position of an element in a vector, which is called position. And let's use it. Let index equals, we iterate over our months. Because it's a vector, we can iterate over it. Then we call position on it. And position takes a borrow to an element. And if this element equals our element that we are looking up, then we have a valid position. Otherwise, it will continue to go through the iterator, and, well, if it doesn't find anything, then we simply return an error. You know what? Come to think of it, an option might not be the worst idea. So let's make an option out of this. Because then we can simply run this operation here and deal with the result somewhere else. But I guess this won't compile yet, because we get a U size, but we expect a U32. So here we say U size. And then down at the bottom here, we need to convert that to a U32 and handle the error case. So here we say okay, or else error parse error. And we return this parse error right away. And we parse that to a U32. Nice. It compiles, but it doesn't work yet, because we forgot one important thing. Our vector is 0 based and our months are 1 based. So let's match on this result. If we have some index, we simply return index plus 1. And in the case where we have none, we return none. Let's see if this works. Sum index plus 1. Because we return an option always. Okay, one step further. The only ugly part is that we cannot handle single digit days. If I add a test with a single digit, so for example 1st of September 2015, this won't work. Get a parse error. So we need to deal with that. When I speak of first, second, third, I always speak of this suffix, but in fact, the ending is called an ordinal. And what I saw a few people do was writing a function for it to split the number from the ordinal. Let's do that. The interesting part is right here, and we can replace this with let day u32. I guess this is going to be a result of u32 because there can be an error. We say parse day from parts 0. Now, in fact, I don't want result here. I want to return that error right away. I move that into our new function, parse day. It takes a string, str, and it returns a result of u32 and error. We don't need that anymore because this is our day with suffix, with ordinal. Let's try to extract all of the numbers from this string. Day with ordinal dot chars dot take while, and as a predicate we say C is digit, collect, and similarly we can get the ordinal with skip while and collect. Then we can match on both. And so we have a lot of cases. Let me enumerate all of them. So in those cases, we return an okay. We return a tuple. And in any other case, we return an error. An invalid day error, which I'm gonna define right up here. So I'm adding errors as I go. And there needs to be no error here. By the way, I just remembered that I forgot a month in my listing here. October is missing. Okay. Then on the caller side, we get result of a tuple now. which is the ordinal and the number. Actually, the result is already carried over to the calling function, so we only are left with the tuple. Let's fix the compile errors. I was using exclusive range patterns by accident. I wanted to have an inclusive range pattern here. Okay, and now I have a conversion error. I get an iterator of chars, but I want, of course, an U32, and I can do that by simply calling parse on it and lifting the error. And I guess I will simply add a type annotation here to make it easier to understand my intent. Well, and it needs in fact, it needs a type annotation here. So we collect that into a string. And instead of collecting the ordinal into a stir, it's easier to use an own type here. So we collect into a string. And as a result, we don't actually return only a U32. Well, we don't care too much about the ordinal really, so we might as well just return the U32 here. Down at the bottom, we just return the day then. Okay, compiler will help me guide along. And now I need a reference here, so I say .asRef. And then we need to fix our output type because we changed it from a tuple now to a simple U32. Okay. Now we finally can parse one-digit ordinals, one-digit numbers for the days. One thing I like to do is rename this method to parse month to make it symmetric to a day. One could also think about a from implementation for date, so you can convert a string right into a date. But I guess the more important part is to give this a proper round of testing. And while I could write my own tests, I probably will forget a lot. And this is why I was thinking about automated tests. And I was looking around for crates that did that. And one of them is proptest, which is similar to Quickcheck, which is coming from the Haskell environment as far as I remember. And it's a very nice way to computationally generate all of the different input cases and checking if your code fulfills them. Or better, can handle them. This works by adding proptest to my crate. Extern grade proptest. We can use it now. I guess it needs macro support. Macro use. And then down at the bottom at my tests, I can now add the first prop test, which is consisting of a macro. And inside of it, you have a normal test cases. And one of the simplest test cases is checking if the parser doesn't crash with any input. So what this means is you can give any name to this function. You can have, it will have one input parameter, which is some kind of input string. And this PC star means it can be any input that you can imagine. And that will be fed right into the parser, and at least we don't expect a crash. So we don't check for whether the assertion was okay or not okay, but we just check if the parser can handle that. Another curly bracket is missing. Let's give it a spin. Okay, so after compiling, it did not quite work. What I forgot was having config test at the top above my prop test crate. And also there were some parentheses here, which, yeah, didn't make any sense. Well, now it doesn't work because the function is actually called parse date. And now it's doing its thing. So there's a lot going on here. What this basically means is that our function does not crash, which is already a very, very good result. Now, while I was preparing the show, I was in contact with Jason Lingle, who is the author of this crate, and he gave me a few valuable tips on how to improve the testing and the test coverage. And one of the things he showed me, I want to show you right now. He told me to try and add a test for invalid input. You can see that the parameter in the parentheses looks a bit different now. Here we have some kind of block, and we can have any character from 0 to 9, from A to Z, and we can have 1 to 5 of them. Then we have a space, and then we have 3 of those blocks here. And then after that, we have any of those characters and also 1 to 5 of those. So that will generate a lot of different strings which have a roughly similar format than what we're trying to parse, and that will cover a lot of our problem space. Let's run that. Okay, we're doing pretty well. Now here's another one which tests for some valid input, and you can see that the regular expression is getting a bit long. This is why I only check for January. What we are doing here is we get any character from the range of 0 to 2. Then after that, we get any of those options. So 1ST, 2ND, 3RD, and so on. After that, or a couple other numbers, which I was not able to express that easily with a closed formula. And then this off, January, we can also think of February, March, and so on here. And then some kind of random year, which can optionally be negative. And when we run that test, we get an invalid case. This is very nice because now I can show you how this thing works internally. And the way I will do it is I will simply print S here before we execute our commands. And now let's actually not capture our input. You can see that it first tries the third TRD of January, and this is already a crash. And then it tries to reduce that to a minimal case. And it goes back and forth a bit until it reaches the minimal test input, which is the 11ST of January 0, which is of course not a valid date. So what I did wrong here was that I was not able to express that as a regular expression because it's also quite hard. Think about February in a leap year. Well, you have one day more, but not in every year. You want to express it as a regular expression. It just is very hard. So instead of doing this, let's get rid of that again. There's another way to express your test cases with proptest. And that is like so. We can have multiple parameters and we can define ranges. So we say y is in 0 to 10,000, m is in 1 to 13, and d is in 1 to 32. And we can use those inputs however we like. So for example, we can print it. Let's just add the dummy assertion here. Let's give it a spin. Okay, and with output. So this is the data that it's generating. Some random year, some random month, some random day, and it will feed that right into whatever we want. Now the first thing you can do, of course, is to try and parse the date. And we need two parts for that. First, we need to match the ordinal to the day, and second, we need to have human readable month names. So let's start with the human readable month names, and we do that by replacing our range up here with some kind of vector. And actually we already have the vector at the top, so I guess I will make that a global and name it month names and refer to it at the top. So this is gonna go away. It's gonna become a global static. And for that we need to change the types a little bit. So that's gonna be static. It's gonna be a borrow with a static lifetime of string. I guess stir. This can go away now. We can use that down here with the month names. And down at the bottom too. Okay. Okay, so that can be maybe like this. The error kind of indicates that something's going wrong down there. It seems like it interprets it as one gigantic array, which is of course not what I want. Maybe I can just say month names dot iter. Yeah, so we had a problem right there. Internally, proptest is using strategies, and a strategy is just something that can assemble test cases for you. But in this case, we have no strategy implementation for an array. So in this case, I guess we do a quick workaround and not use the iterator on the month names, but instead we just do a quick vector lookup and be done with it. We changed that back to what it was before. 1U32 to 13, exclusive range. Okay, and then we do the lookup ourselves. Let human month equals months. What was it? Month names. Dot position. No. Simply month names M. But then this should be from 0 to 12, I guess. This should return a string. And it needs a usize index instead of a U32. Okay, so it was creating a lot of different values here. And we can now actually use those. But first we need to get the proper ordinal. So we say let ordinal equals match D. I guess I would just quickly write down the ordinals by hand. This can be refactored and combined with our previous ordinal checking, but I guess it's okay for now. So we got the ordinal, we got the month. Let's use it now. Let date string equals format day, the ordinal of the month and the year. The ordinal human month and year. Let's print this. And feed it into our parser. Is that gonna compile? No. We forgot a semicolon. And the year is actually Y. And here we need an assignment. Okay. But we haven't really checked our success yet. And we can maybe start with an assertion, which should fail at some point. We say assert equal, parsing the date will output a naive date from year, month, day. And the year is going to be Y. No, year, month, day. Year is going to be Y. Month is going to be M and day is going to be D. Never forget your parentheses. No, it's just called from Y1, YMD. And then this needs to be cast to a U32. And I'm missing an exclamation mark here. Okay. Wrapped it up into an OK, because we return a result. And we found a bug. It cannot parse the 1st of January 0. That's a pretty interesting one to solve. Maybe you can come up with an idea. I will go to sleep now, and I will continue tomorrow. Remember that the final thing we did was parsing all kinds of valid date formats. But there can still be a few exceptions, like, for example, there's a day which is not available in any given month. So we need some way to check that a date is in fact valid. But how can we do that without rewriting the parser? Well, turns out there's a little trick you can do. In our generator, we already know which date we expect. So we can compare the output of our parsing step with the date object that we are expecting from Chrono. And I can show you how to do that. It's quite magical when you see it for the first time, and it helps a lot with testing things that are not so easy to test and to get full test coverage for. Let's get started. We need to pay a little attention to the month here, because as we've seen, the month is zero based, and so we want to add 1 here because the human months are 1 based. So m plus 1, but that also needs to be a U32. Remember, it was a U size before. Okay, so let's make an assertion out of that. Assert equal, parsing the date should yield the same result as our date object parsing. One thing that I forgot is we want to map our our error case to our internal error case. And that is going to be an invalid date error. Just like we did above in the concrete parsing here, we want to get the same behavior from that. Remember that from year, month, day opt returns an option, but we want to compare results. Yeah. Shall we give that a spin? Cargo test. Not found in this scope. It's not year it's Y. And down here, I forgot that OK or else takes a closure. Nice and sweet. We can also run it with no capture to see which dates it's generating. Now I guess the result here is that this gives us a lot of confidence in our code base. There might and will still be bugs, but at least we can narrow them down to some very constrained edge cases. We test a lot of very, very different things, and proptest or Quickcheck or tools that generate automatic tests can help us a lot with that. If you're interested in date parsing in general, or actually human-like date parsing, there is a repository called Chrono English from Steve Donovan. Maybe you could add some of the date parsing we did today to that library as a pull request if you like. Might be a good exercise, helping out a colleague in the Rust community. Yeah, thanks again to everyone who submitted their code for the challenge. I think that I will do that more often in the future. And yeah, with that said, see you next time.